For those of you who are practicing residential architecture in Austin, then this is an immediate concern perhaps. And if you're not, it might still be interesting because there's a couple of different tools kind of working in concert to sort of help sort this out. So I'm going to be demonstrating with a project that we worked on not too long ago, waiting to roll around into construction. So this is just an ADU, obviously, behind an existing little sort of shotgun bungalow type house. And of course, the ADU is at the back of the lot. It's not, the paving's not modeled, but there's a paved alley back here. And there's always a concern with these two-story structures that you not violate the imaginary tent that's stipulated by what's officially called subchapter F of the Austin Land Development Code, which everybody refers to as the McMansion ordinance. And so there's a couple of key things that that you need to be able to work out the tent. One is you have to have a good site model. The recommendation, of course, is that you have a qualified registered surveyor perform your survey for you and give you your starting points for the tent, this imaginary envelope. And there are times where probably against good caution, we may be forced to rely on something like the Austin GIS server to get access to 2-foot interval contours that are based on photogrammetry. Those obviously are not going to be as accurate as a real survey done in the field. Oftentimes, the tent isn't really an issue. It's something that you have to get through and demonstrate that you comply. So if you're off by a few inches, that's probably not going to matter. And of course, if you are designing right up to the tent, then it's advisable that you have a proper survey. To be honest, I don't remember what we had for this particular project, whether we used GIS contours or a survey, but the principle is the same. So obviously you can tell from the solar array that that roof is facing south, the alley is north, and this existing house is if you'd like peek through the windows, you can see that there are no internal walls. We just modeled, measured and modeled the shell. There's some things here I don't know. I don't even know what those are, but that's okay. They're not relevant. For the tent, again, you're going to need a survey and some contours. And the way this imaginary envelope is calculated is you start with a building line, an imaginary building line, and that line is going to be parallel to the front property line, and it's a line that's parallel to the property line and then intersects the forwardmost portion of the building. So in this case, it's going to be this little roof on this front porch. We don't count the steps. And then you start creating 40-foot sections from that initial so-called building line. You go back 40 feet and you build a tent. And then you go back another 40 feet and you build another tent, and you keep going until you run out of sight. And so the tent is a 45-degree angle, and it starts 15 feet above one of the four corners of the tent, the one that is highest relative to sea level. And this will all be a lot clearer when I kind of go through it. So oftentimes I've seen this tent sort of generated with like extrusions or things like that. And I have another technique that I think is a little easier to deal with. So here's our site. Pan back a little bit. You can see our ADU here is grayed out. There's the main house. Here's the property line that I'm highlighting by hovering over it. Right there, the front property line. There's the sidewalk in the street. And here's the roof. Now, obviously, sometimes the roof is parallel to the property line, or whatever protrusion from the building is parallel to the property line, but sometimes it's not. And so what I'm going to do is, let me minimize this. There we go. What I'm going to do is, here's a roof plan of the existing building. If I hold down the B key, you should be able to see through the existing walls there. Okay. So what I'm going to do is I'm just going to draw a line, and I'll go ahead and deselect this site. All right. I'll beef up my line weight just so you can see a little more clearly. And what I'm going to do is I'm going to draw a line, and I'm just going to snap it from this endpoint to that endpoint of my property boundary. So there it is. And from there, I'm going to use my offset tool, which is right over here. And typically, I'm often offsetting by a specific distance, right? That's in this mode over here. But in this case, I'm going to offset to a point. So wherever I click, that line is going to be offset to. And I'm going to click on the corner of this roof. And if I zoom in here, you can see that I've just, by a tiny little smidge, you know, 1/3 of an inch, I've just missed that roof. So they're not quite parallel. I just guessed and snapped on that corner of the roof. I could have snapped to this corner, and then I'd have been in, and I would have needed to adjust. But this establishes the building line for my tent. So I'm going to take that line, and I'm going to hold down the shift key so I don't mess up the angle. And I'm just going to have it go a little bit beyond the property line. So there's the beginning of my subchapter F, imaginary tent. And now I'm going to go back to my offset tool. I'm going to do this again, only this time I'm not offsetting by point mode. I'm going to offset by distance mode, and I'm going to set that distance to 40 feet. And so now I'm going to offset it. Oops, let me undo that. I need to offset and duplicate. I want to keep the original building line. So there's 40 feet, and there's my first section of my tent. It's going to be bounded by this top property line, the bottom property line, and the two black lines that I've just drawn. Here, let me change them to some even a little more garish color so that we can see it nice and clearly. There we go. All right. So let me click this line, select that line. Now it's being hidden by the roof because of the stacking order of my layers. I'm drawing on my site layer, and the roof layer is stacked over it, but that doesn't really matter. In fact, I'll go, now that I've had a point to snap to, I can just turn that roof off. Let me go back to this. Okay. And actually, you know, I like the one I had before. Let me go back. There we go. So let me go ahead and offset again, another 40 feet, and then another 40 feet. And this one's kind of tricky. In retrospect, I probably should have fudged the the project that I chose, because you can see I just have a tiny little section. It's like 2 inches wide. But I got to take that into account if I'm going to play by the rules. So there are the sections of my tent. So just to show you, here's that site model, right? And so in top plan view, it's got contours. Back to my save view. In top plan view, it's got contours. And the reason the site model is so great in Vectorworks and why it's such a useful partner in this exercise is that unlike an extrusion or some sort of sculpted surface, right? You could just build your site model by just creating some contour sections and just extruding them and building them up like you would an old corrugated site model, like maybe you did in school, or chipboard model or whatever. But this site model pretty much it's very self-aware. It knows kind of every point what its elevation is. So now that I've established the intersection of these 40-foot lines with the property bounds, what I can do is I'm going to pull in another Vectorworks tool, and not from my 3D modeling palette, but from my site palette. And that's a stake object, this one right here, stake tool. And there are multiple modes for that stake tool. But what I'm going to do is I'm going to snap that point right here at these intersections. I'm just going to drop a stake there. And if we look at it in the object info palette, you can see that I have multiple modes here. I can include a site model data, use as a 2D graphic only, create a site modifier object out of it. What I want to do here is set elevation to site model. So I'm in a rotated view. So right now the text is upside down. Sorry about that. Let me see if I can fix that. No, that doesn't do anything. Maybe a 90-degree rotation will make this a little more legible. Yeah, that helps. All right. So there's the elevation at the intersection of the building line and the property line. And I'm going to repeat this. In fact, what I can just go ahead and do is just take that stake object, now that I've got it configured just the way that I like. And I'm just going to do a move by point. So this will be a move and duplicate mode. And I just want one duplicate, and I want to keep the original. And so I'm going to snap from the insertion point to that insertion point, that intersection. And you can see that because this stake object has set elevation to site model, right? That's the mode of that object. Oh, and by the way, there are two potential site models. I'll get back to that in just a second. Let me just finish my sentence. Because this is a stake object whose elevation is set to the site model, it is reporting the elevation at that point on the site model. And that's why I'm getting 458 feet, 10 inches basically at the first one, and 459 feet, 6 and change inches at the second one. Not because of anything I did, it's just reporting what the elevation is at that point. Now, site models in Vectorworks can be modified. And so before you modify a site model with site modifiers like grades or pads or whatever, you have your initial site model that you've built from your survey, and that is the existing site. But I also could have a proposed site. So if I've got any kind of site work, then Vectorworks will display the proposed versus the existing. So it'll show, say, existing contours dashed and proposed contours solid, or vice versa. Now in 3D, I can only show either proposed or existing, but in 2D, I can show proposed and existing. And I don't think there are very many, or perhaps no, site modifiers other than texture beds on this on this site. But the stake object can report either the existing or the proposed elevation at that point. And you want it to be existing because the subchapter F of the Land Development Code stipulates that you are to take these elevations from the natural grade prior to your construction project. I've heard of people being sneaky and like building little mounds. I don't see how you could get away with that if a building inspector pays any kind of attention, but in any event, go ahead and have your stake object report the existing elevation, not the proposed. All right, so now I've got these 2 points established. Let me go ahead and I'm going to beef up my text style, text size, so everybody can see nice and clearly. I'm going to take this one and I'm going to repeat what I did before. I'm just going to do a move by point from the insertion point and again to this intersection. And there's that. And then there's that. There we go. So now I have, I'm going to go ahead and make my roof invisible here. So now I have 459.11, I have 459.6, 458.10, and 459.8. So the lowest point obviously is 458.10, and the highest point is 459.11. And that's obvious. I mean, it's right here, right next to this contour, which is probably the 460 elevation, I'm guessing. Right. So I could have just calculated all of this by just drawing a line, a perpendicular line between 2 different contours, and then figuring out what fraction of the length of the line was from the higher contour to the intersection of the building line and so forth. But that's just use the stake object. Everything's so automated. So why do I care about that? Because the McMansion tent is going to start 15 feet above the highest of these 4 points. That's what determines where this imaginary tent begins its 45-degree ascent or slope. So it's critical that I know all 4 of these points, that I be able to demonstrate them on my construction documents, and that I, make bold or highlight or circle or point out what the highest point is within this 40-foot zone. Any questions so far on the interactive site model or stake objects, or how I've been offsetting, or any of the stuff that I've talked about so far? Please unmute and chime in, or say, no, this is all clear as mud.
No question.
Okay. Yeah. Sorry, was somebody going to ask a question?
No.
Oh, okay. No questions. All right. All right. Terrific. Then I could go ahead and repeat this, but I'm gonna go ahead and go and build a section of the tent. So the next tool that I want here is my 2D polygon tool. Now I could use a rectangle, except it's very likely that while this zone bounded by the property lines and the building line and its 40-foot offset, that appears to be a rectangle, it almost never ever is. It's usually some slight distortion, some little trapezoid or something like that. The side property lines are usually not perfectly parallel. The building's usually not perfectly parallel to the street. There's always some little discrepancy. So I'm just going to draw a polygon by point mode, by vertex mode. I'm going to zoom in here with my snap loop. That's a Z key. I'm going to click here and drag over here and click and click and click, and then just finish. Right. So I now have this polygon. And it's reporting a width of 40.1 inches, and that's because it's a slight trapezoid. But what I now want to do with this is I want to use this to build my tent. And so let me go over to my resource manager and let's look at my roof styles. There we go. And you can see that I have a roof style called McMansion tent. So let's have a look at that. It's very basic. We'll just go ahead and double click on it. No? Okay, we'll go ahead and edit it instead of applying. So this is a roof style. It just has one component that I've called tent. And I even have a class for this, site-tent. And then if I edit it, it says the thickness is 0. That's actually not true. I suspect that the thickness is actually something like 0.0001. Anyway, in the past, I've had to not be able to give it a thickness of 0, but I give it a thickness of like a mil, 1,000th of an inch or something like that. And that has a texture, which is a translucent texture that is assigned to it. So let me cancel out that. And that is all that is in this roof style. So I'll just cancel that. And if we look at our textures, in case you're interested, there are a lot of textures here. I think it's in this translucent medium texture. Might be translucent very high, but let's go ahead and edit that. It's very simple. It's just the color is whatever the object attribute is. So whatever it'll be tinted by a color based on the object that it's assigned to. And the transparency is just set to plain. And then I've got it to something like 20% opaque or something like that, right? So it's very, very transparent, but there's still enough there to show me what's going on. So let me cancel out of that and close my resource manager. So now that I've got this, this polygon that I've drawn for my 4 points, I'm just going to go to AEC and I'm going to create a roof. And I'm going to pick a style, which is my McMansion tent style. And I'm not going to put it in the roof main class. I've got a class that I already showed you before called site tent. There it is, which is currently invisible. So there's site tent. And I'll leave it on the layer site. And now here's what's interesting. The roof pitch I'm going to say is 45 degrees because that's what the subchapter F of the Land Development Code stipulates for this imaginary tent, that it starts 15 feet above the highest of these 4 points that we staked out on the site, and that it then proceeds inward towards the center of the lot at a 45-degree angle. So I'm making this roof with a 12-12 pitch. And then look at the bearing height. So the bearing height is by default set to 463. And I'm just going to look around at my 4 little points, one of which is obscured, but I can see that it's 459.11. So I'm going to type 459 feet 11 inches plus 15 feet. And I want 0 eave overhang. And the eave cut, it's got a thickness of virtually 0, so it doesn't really matter whether it's a double cut or whatever. And there we go. And I can retain the original object or not. I'm not going to. And that tent is gone because that class is turned off. So let's go ahead to the navigation and find the tent in my navigation browser. Now I already have a tent here, so I'm going to delete my other tents. All right, so there's the tent that I just created. And let's look at that real quick. So there's that tent. You can see, sure enough, it's translucent and it's red and beautiful. Only it's a hit because, of course, Vectorworks makes roofs by default as hipped roofs. So I'm just going to go and click on this point and make it a gable, obviously with no end wall. And then I'll make it a gable over here. All right, and there we are. We're in the clear, obviously, by quite a large margin. And we're starting 15 feet above this point down here where we drew the stake. Let me go back. There we go. So there's my first section. So now I'll just go ahead and go back to my exercise of popping in some stakes. And I'll, oh, you know what? I think I said that I would just, instead of redoing the stake, I'm just going to take this one and just do a move by point and use the snap loop so that I'm really in the right place. You can see that my heads up display is giving me a length of 40 feet, so I'm good there. And then from here, I'll go down to there. And from here, I'll go down to here. Boom. Now, I already have that one. I don't need it twice, right? So now I've gotten my second 40-foot zone bounded by these two green lines and the side property lines. This is at 459.11. This is at 461.11.3, 460, 450. So, you know, if you just looked at the contours, you could guess that this is the one that's going to be the highest, right? So I could redraw the polygon and do another tent, but I'm just gonna option drag this tent and then reshape it. So using the reshape tool in the vertex mode, and just move that corner to this one, and move that corner to this one, and move this one to, hold down the B key so I can see what I'm doing. And the snap loop and snap there. Only this one is the same height because it's just a duplicate as that one. So, all right, we said 461.11.3. So I'll just snap on this endpoint here and change this to 461 feet, 11.3 inches plus 15 feet. And make sure and click entire roof so it automatically does it for the other side. Why? Because that's what the ordinance says. So again, we can have a look at what's going on here. And there's my second tent. And you can see, as expected, it's a little bit higher than the first one because that next zone, which you can see quite clearly where I've got this little shed, that zone is stepping up. I think I've lost some site modifiers over here, but that's okay, no matter. Doesn't affect what we're doing here. All right, so let's go back to where we were and we'll rinse and repeat. Now here it's getting a little tricky. I'm gonna zoom in, move by point, and you'll remember that I had 2 points. So there's a stake object there. And I'll snap in over here. And I already have this point, right? So I just needed to add 2 more points. So once again, I can inspect all of these points. Here's 461, here's 463, here's 462. Obviously, once again, this bottom left corner is going to be the one that matters. So I'll just option drag to get my tent, and then I'll just reshape point by point. I'm using the zoom loop to snap in and make sure that I'm getting the correct intersection.
Do you really need, Francois, to reshape it? Because isn't it just moving over 40 feet?
Yeah, so if my 2 side property lines are perfectly parallel, no, I don't need to reshape it. But sometimes the property lines are slightly divergent or slightly convergent, depending on how you want to look at it. So just to be safe, I'm going to draw it. I'm going to reshape it. Because you can have like, and this technique works even if you have like some weird pie-shaped lot,
Got
right?
it.
Where each 40-foot section would get bigger and bigger and bigger, or smaller and smaller and smaller, depending on, you know.
I see.
Usually the pie-shaped shot is pie-shaped lot is narrow on the front side, but you never know. Okay, so once again, holding down the B key so I can read what this says, 463.9. So again, I'll click on this point and I'll type 463 feet, 463.9 feet plus, oh no, that's not right. It's not 463.9, it's 463 feet, 9 inches, right? Plus 15 feet. Make sure I click entire roof. No, and that's wrong. It's 463 feet. 0.9 inches plus 15 feet. I knew there was a decimal in there somewhere. Entire roof. Okay, well, here's where it gets a little tricky because subchapter F also stipulates that when you get to the back of the lot, starting at the rear property line, you also start to slope at a 45-degree away from that rear property line towards the center of the lot, which means what was gabled over here is not going to be gabled. That's going to be another 45-degree eave, same bearing height, right? And depending on the width of your lot, obviously, if your lot is more than 40 feet wide, then that hip, that imaginary hipped roof, if you will, could actually span 2 or more of these sections of the tent. And then finally, right, as silly as it may seem, but just because sometimes, you know, you just do get these weird little situations. We have this tiny little 2-inch sliver of a tent right back here. So I'm going to go ahead and do another duplicate by point and move this guy over. And you can see that is, hold down the B key, that is actually 1/10 of an inch higher. Thank goodness for that. At least according to my site model. And then I've got another one here, 1.7 inches over. And that is also 1/10 of an inch higher. And so now I have this tiny sliver of a roof. So I'm going to go ahead once again and just option drag because it's just easier to do that than to redo the roof command. And I'm going to zoom in real close with my snap loop and snap here. And then this little vertex, I'm going to come in right here, hold down the B key so that I get the right point. And then this one goes over here. And then this one, hold down the B key so I get the right one. There we go. So I have this really skinny little roof. And again, the high point is 463.1. So I'll just click on that and make this 463 feet, 1 inch plus 15 feet entire roof. Boom. Now, the last thing I need to do to adjust this tent is, and it's maybe less obvious where I have this tiny little sliver at the very end. If that were a more substantial sort of tail end, like say 10 feet wide, it would be more obvious. But if I go ahead and take a perpendicular view, so I'm just going to sight along this rear property line. And so I'm going to go to view, set 3D view, and I'm going to snap from this endpoint to that endpoint. So that may be an edge-on left view, but it might be just a little bit off. And then I'll make that an orthogonal projection and hit OK. And then here's my site model way up here. So I'll zoom in. So you can see there, this little triangle, that's the that 1.7 to 2.1 inch wide tent at the very back. And then here's the next zone over. So I'm just going to draw a line and from kind of up here, and it looks like what I need to do is click on this endpoint and add about 2 inches to the bearing height. Now, you know, maybe it needs to be at this top, or maybe it needs to be over here. It's a little hard to tell. This is going to be close enough, but basically I'm going to manually adjust just by inspection, go back and forth and adjust this height so that what I get is more or less an even plane. And you can see there's a little bit of a triangular gap here and a little bit of a triangular gap there. But there's my tent in all of its glory. And so site models, stake objects, roof objects is how I build that. Now, you'll note that part of my gable end is sticking out on this ADU. And that's okay, actually, because subchapter F allows side gables and dormers to extend outside the side planes of the tent by up to 18 feet. So long as the width of this is less than 18 feet, that's perfectly allowed. What's not allowed under any circumstances is for anything to protrude out the back of that that tent plane. I think that's something that people miss sometimes. They see that gables and shed roofs and dormers are allowed to penetrate the tent, and they assume that that also applies to the side or to the rear 45-degree plane. But that's actually not the case. It's only the side planes where you can protrude out the side of the tent. So so great. I've got the tent in place. Obviously, if I've got a remodel situation where, for example, like this project where I've got an existing house and I'm adding an ADU to the back, I know where my building line is, right? But sometimes I don't know where my building line is because I'm designing a house and it's going to create the forwardmost projection. So I can't start with a blank site and just put a tent on it and assume that that's going to be 100% correct. I can guess where the front of my proposed building will be based on front setbacks and how much allowed forward projection I have for a front porch and a roof and all of that. But I'm going to need to adjust that tent to meet the final design, because that first building line, the very first one that we drew, is going to have to pass through the forwardmost roof or wall projection of the forwardmost structure. So it'd be nice if you could just, you know, start a project and just throw your tent up and then you can just design up to the tent. But it sometimes there's a bit of a back and forth. But as a design tool, obviously invaluable if you're doing projects, particularly two-story projects in the central city. But now I've got to document this, right? So I've got to be able to demonstrate in my construction documents that I'm respecting the tent. So let's go look at that. So here's a set of part of the working drawings, and you can see that in this elevation, I've drawn the building and I've shaded the portion of the gable that is protruding beyond the tent. Well, how did I know that? Well, real simple. What I do is in my viewport, I go ahead and go to my classes and turn the site tent on, and then I update the viewport. And when you do that, you can see I go inside the annotations, I'll just delete this rectangle. You can clearly see the portion. In fact, I'll go ahead and delete all the annotations. So there's the unadulterated model. So the tent is, even though the texture is translucent, the tent is rendering as a solid. You can see it here in section. Right? It actually does have some minute thickness. And so what I can do is just, trace the portion of the roof that is extending beyond the tent with a polygon. I'm being a little sloppy, but you get the idea. And then I can go ahead and, once I've done that, turn off the tent and update my elevation. And so now I can document that in 2 dimensions and dimension it and assure the building official, the plan reviewer, that I'm not, I'm not going beyond the tent by more than the allowed amount. So same thing over here. The tent graphic that you're seeing here in the viewport annotation, excuse me, that's just a polygon that we drew by tracing over the tent. And so you can see that we're calling out the high ground, the high point of that 15-foot. We're dimensioning the 15-foot here. We're got a 45-degree dimension to show that this is the actual dashed line of the boundary. And then we're shading the portion that's extending beyond the tent and referring them back to the other elevation. And so there you go. That's how that works. So it's not only a helpful model for your 3D design process, but ultimately that tent object is going to play a role in your being able to accurately draw your elevations and show where you are within or outside of that boundary. And then techniques like that aren't just limited to the tent. This is a bit simpler, but here we've got a power pole in the alley, and so we measured where the neutral wire was. And then we drew a 15-foot radius arc and extruded it. And so if I'll just delete this. And so this is a bounding, a boundary that is required by Austin Energy. And so, that's going to tell us, yeah, maybe on this north side, we don't have much of an overhang, or that helps us decide what our total wall height is, obviously, or how far back we are from the alley, and this is something that that you can go ahead and establish right at the beginning, because that's based on the power pole location, not any of your design work. So that's it. That's all I got today. Hopefully you guys have some questions. We can stretch this out a bit. But I just I like this little exercise because it's an opportunity to use the roof tool and the stake tool and site models in a way that that we don't usually get to do. Any questions?
I have a question, Francois.
Yeah.
In your construction documents, when you're showing the elevations, you're just showing the highest one? I mean, are you not showing from multiple sides or the various components of the different tents?
Yeah, so let's go back to that sheet. So you can see here, I'm showing the alley, and I'm showing that back tent, and then I'm showing the next one. Everything else here is outside the scope of the project. So I suppose that when we submit for permitting, the building official could say, no, I want to know whether your 1930s bungalow is, respecting the tent. I mean, it's not really relevant. But normally, if we were developing the entire site, we would show the entire, each one of these 40-foot McMansion sections. And sometimes it's tricky, right? Because you've got a site where, again, the side property lines aren't orthogonal or parallel, rather. And so do I show the elevation skewed? So it's a bit of a call as to, how best to display this in a way that is clear to the building official that you're not violating the tent. Here, the ADU is just in one of these 40-foot zones, quite coincidentally, right? Like we're just barely, so I didn't really need to show more. Here on this end elevation, sometimes on the project, I might show, depending on the project, I might show multiple tents, and I would label each of these parallel dashed lines, McMansion zone 1, zone 2, zone 3, zone 4, whatever, so that they understand that, yeah, we're outside the tent illegally, but it's a section of the tent that is either forward or back from this elevation and therefore not relevant. Does that answer your question?
Yes, it was those transverse cuts through the tent going back and forth that I was wondering how you decided how to handle that.
Yeah. I picked an easy one because there's just one section, but sometimes there are multiple sections, and then we draw them all and then label them.
Good, thank you.
Lloyd, I have no idea how AI is going to affect Vectorworks, but I can ask ChatGPT what it thinks.
Yeah.
Francois, on the Austin Energy, the blue thing that at the back. So it was scooped along the back because it's assuming that the power lines are running parallel to that back property. Is that?
Yeah, they are. Yeah, we went out and measured them, and obviously the power lines are catenary curves. So I guess you could model a sagging cylinder or something like that. But we just assumed that it's a straight line. We measured how high it was off the ground. Sometimes you can read the ID number off the power pole, and you can contact Austin Energy and ask them, this specific pole, is it a 40-foot pole? Is it a 35-foot pole? Is it a 50-foot pole? Whatever. And they'll tell you what the heights are for, the neutral wire and the active wire at the top. And so sometimes we get, that's why you're seeing these two scoops, because this pole has another power line.
So if the
on
line,
an arm,
if the line terminated at that pole, would it be more of a blue arc? I mean, a partial sphere then?
that's not what Austin Energy says. There are no spheres in their world. They're just cylinders.
Oh, okay. Because I was thinking, like if it ran parallel on the adjacent property, but then kicked across the alley, right?
Yeah, or if it was like right in the middle, and then it went across the alley, it would just be two cylinders, coming together at a chamfer.
I see. Okay. All right. Thanks.
Yeah. And I guess I could get creative and model those with like a giant duct, a 30-foot diameter duct, Vectorworks duct object or something like that. But just drawing an arc and extruding it did just fine. Cool. Any other questions?
Francois, I've never dealt with this before. Is this applicable only in certain areas of Austin?
Yeah, it's within the central city, but that said, the boundaries of subchapter F are they're quite, they're not, it's not like downtown only, right? It goes out to 183 and William Cannon and you know, it's if you look up Austin McMansion tent map or something like that, you'll see it's a substantial area. The vast majority of our Austin projects are within that area. You know, in some of the more distant suburbs, it wouldn't be applicable. And the other thing to mention is you only have to present a tent. You're always responsible for not violating the tent, but you only have to prove that you're not violating the tent if you have a 2-story project or one with walls that are 15 feet or taller. So if you're just doing a 1-story project, they don't ask to see your elevations with the tent drawn. And obviously, if it's an interior remodel only, that's not relevant. But for an awful lot of, you know, for more than half our projects, we have to do this. So just figuring out that we could use roofs instead of extrusions was like, it's really nice, kind of a time saver.
Do you ever include like a 3D view of the tent to describe zone 1, zone 2, zone 3, just for clarity for the reviewers, or would that make their head explode?
I have not. I tend to prefer to give them enough information to make my case and not too much. But I have had informal meetings with plan reviewers where I brought in my laptop and showed them a model of the tent. There was a project where we were already under construction and the owners decided they wanted to add more square footage. But that's always fun. And so everything came to a screeching halt. And you know, we basically had to reapply for a permit. So we were strategic when we did all that. But once you apply for a permit or to make a major amendment to a permit, then everything stops. No further inspections are allowed until you've been granted your new permit. So we were strategic and just asked for all the inspections that we needed so that we could keep working while we were getting the new permit. But I digress. So yeah, just to demonstrate to the plan reviewer that, you know, we weren't going crazy. I walked in with a model of the project and the tent and showed them that, you know, we were, I'm exaggerating, miles from, I mean, tens of, you know, over 10 feet from hitting the tent before, and that was more or less still the case with this addendum. So I have done that, Don, but I haven't included like little isometrics. So, you know, there may come a day when I'll need to.
Got it. Thanks.
Yeah.
I have.
Oh, and how did that go?
It went pretty well. It was a complicated site where the back was like 7 different angles, and they wanted to see how I was calculating it for that. And I showed them, and they were like, "All right, that works." So I get
Cool.
kind of isometric on the drawings.
And did you use like just extrusions, or did you use
I
the roof
didn't
tool?
use the roof, and I didn't use the stake objects. But now that I've seen this, I'm completely going to change how I do it. This is much better. I was making basically columns, 15-foot columns, and thin, really thin extruded angle planes. So it looked the same, but this is a much better technique. Yeah,
and I probably should have shown like a really tricky site with like, you know, 7 different property line segments. This works for that as well. Like I've never not been able to model a tent using a roof like this, even if your front property line is an arc, like you're on a cul-de-sac or on a curve. the ordinance is clear that you are to take where the property line, where the building line, which is a straight line, intersects the side property lines. So you don't have to worry about like scooping out a circular whatever in the front. It'll always be a straight edge, and then you just march it back. And you know, Vectorworks roof objects will handle quote hips with, you know, not just 3 edges, but 4 or 5 or 6, no problem.
And really using those stake objects with the site model is life-changing for subchapter F. I mean, that's
Yeah.
really the hardest part, is getting those elevations figured out. But this is beautiful.
Cool.
Instead of dreading subchapter F, I look forward to putting one of those together again.
All right, well, when you do, if you get stuck and you have any questions, shoot me an email.
Thank you very much.
Yeah. All right. Well, I don't see anything else in the chat. I think we pretty much covered it, and I'll be posting this to YouTube as usual. And of course, always welcome to send me questions or suggestions for future topics.